Hello friends, our today's video is basically aimed at to explain you the brief concept of J flip-flop. This video is designed by the students of St. Vincent Pallotti College of Engineering and Technology, and the names are Vaishnavi Vadaskar, Sonu Dupare, Mrinal Badole, Shivani Korvatkar. We were guided by our professor Swati Midlekar ma'am. Objective of this presentation is to make you aware about the concept of flip-flop, and we hope that at the end of this video you may have understood the concept of flip-flop and its types. So before going towards the main body of this video, let us first see the contents of this video. The first slide would be about flip-flop. The second would be of applications of flip-flop, and the third would be types of flip-flops, and at the last there would be an activity known as brain hammering. So starting with our first content, that is what is flip-flop. So in digital circuit, the flip-flop is a kind of bistable multivibrator. It is a sequential circuit, an electronic circuit which has two stable states and thereby is capable of serving as one bit of memory, bit 1 or bit 0. So before moving towards the types of flip-flop, we want to tell you what are the applications of this flip-flop, where it is basically used in memory circuits, in logic control devices, in counter devices, in register devices. So the types of flip-flop, which are SR flip-flop, which is subcategorized into SR flip-flop active low, SR flip-flop active high. Second is clocked SR flip-flop. Third is JK flip-flop. Fourth is T flip-flop. Fifth is D flip-flop. Sixth is master slave edge triggered flip-flop. Starting with our first type of flip-flop, it is SR flip-flop. The SR flip-flop has three inputs: clock, set, reset. Clock, which is denoted by the symbol CK, set with denoted by S, reset is denoted by R. The Q output of an SR flip-flop only changes in response to an active clock edge, which can be positive edge triggered or negative edge triggered. The logical diagram of SR flip-flop can be drawn using NOR gate as well as using NAND gate. At below you can see the table, which is a truth table. The first two states where there is no change, and at the last there is an invalid state. So this last state is explained as this: if S and R are 1, both the output Q and Q dash will try to become 1, which is not allowed, and therefore this input condition is prohibited, and that's why it is invalid. Second is JK flip-flop. It is a flip-flop. It is a flip-flop, a circuit that has two stable states and can be used to store state information. It has 5 inputs named J, K, PR, CLR and CLK. The JK contains an internal active low SR latch. This is the block diagram of JK flip-flop. These are the truth table and logical diagram of JK flip-flop. The important state of JK flip-flop is toggling, which is shown at the last row. When J and K equal to 1, it is possible to set or reset the flip-flop depending on the current state of the output. If Q is high, the lower gate, that is NAND gate, passes a reset trigger on the next clock pulse. On the other hand, when Q is low, The upper gate passes a set trigger on the next clock pulse. Therefore, when J is 1 and K is 1 means the flip-flop will toggle on the next positive clock edge. Toggle means switch to the opposite state. The characteristic equation of JK flip-flop is basically next state equal to J present state and K present state. So our third flip-flop is T flip-flop. In JK flip-flop, if J equal to K, the flip-flop is referred to as a T type of flip-flop and is shown in this figure. This is the block diagram of T flip-flop. This is the logical diagram of T flip-flop, and at the below you can see the truth table of T flip-flop. When T is 0, when clock is triggered at high, the status is hold, and when T equals to 1 and clock is positively triggered, the status is toggle. It will attend the next. So the next type of flip-flop is D flip-flop, also known as data flip-flop. Can be constructed from RS flip-flop or JK flip-flop by addition of an inverter. Here you can see the logical diagram of D flip-flop, and at the below there is a truth table. It has only one input referred to as D input or data input. If D equal to 1, J or S equal to 1 and K or R equal to 0, therefore Q equal to 1. And if D equal to 0, S or R equal to 0 and K or R equal to 1, therefore Q equal to 0 as shown in the truth table. From the truth table it is clear that the output of the next state at the end of the clock pulse equals the input Dn before the clock pulse or Qn before the clock pulse. At the last, the type of flip-flop is master-slave JK flip-flop. A master-slave flip-flop is a combination of two clocked latches. The first is called the master and the second is the slave. The master is positively clocked but the slave is negatively clocked. This implies the following. So the first state is set. To start the analysis, let us assume low Q and high Q dash. The master goes into the set state producing high S and low R. Nothing happens to the Q and Q dash outputs because the slave is inactive while the clock is high. Next state is reset. When the slave is set, Q is high and Q dash is low. The master will reset forcing S to go low and R to go high. Again, no changes can occur in Q and Q dash because the slave is inactive while the clock is high. Now, the next state is toggle. If the J and K inputs are both high, the master toggles once when the clock is high. The slave then toggles once when the clock goes low. No matter what the master does, the slave copies it. If the master toggles into the set state, the slave toggles into the set state. If the master toggles into the reset state, the slave toggles into the reset state. The explanation description is given here in brief, which you can refer. Brain hammering. So here we come to our activity at the end of this video. So our first question is, an SR flip-flop can be converted into a T flip-flop by converting to Q bar and to Q. So basically how SR flip-flop can be converted into T flip-flop. So the answer is S to Q bar and R to Q. Now moving towards our second question, how is a JK flip-flop made to toggle? And the correct option is D. There are furthermore questions which you can refer. So I would not be saying all the questions. You can refer it. So thank you for watching this video. We hope you may have understood the concept of flip-flop. This was our first YouTube video, and we have tried our best. Hope you may have liked it. So thank you.